Hi there, in this video we're going to learn about functions. Your objectives for today are to determine whether a relation is a function and to write functions using function notation. So a function is a relation in which each element of the domain, the x values, is paired with exactly one element of the range, the y values. So all your x's are the domain and all your y's are the range. So here is an example of a function. If you notice, all the domains have exactly one output. So this is a function because each domain value is paired with exactly one range value. Here on this side, this is not a function because this 2 has two different outputs. It has 1 and 3. So this is not a function because 2 in the domain is paired with two range values. Okay? So every input has only one output. Every input should have only one output. So this has two outputs. So this is an example that's not a function. Now you can have two of the same domains. You can have two of the same ranges, but you can't have two of the same domains. See, like 2 goes to 1 and 3 here. You can't have this. But if you had 5 and 9 going to the same number here, like 4, you can have that. All right, so independent variable, this is chosen. This does not depend upon the variable, and your domain has them. So basically, in your domain, this is where you're going to find your independent variable. Your dependent variable depends on the values of the domain. So the range actually has them. So this is the range, dependent variables. Independent, dependent. These depend on these. All right, so let's look at this. Is this a function or not? Well, if you scan through all of these, we have two 54s here. Now, can we have two of the same domains? Let's see. This is not a function because 54 and 56 in the domain are paired with two range values. So if you look, you've got a 54 here paired with 112 and a 54 here paired with 123. So that makes it so that's not a function. You have 56 here that's paired with 130 and 56 here that's paired with 128. So that also makes this not a function. So this is not an example of a function. Here we have x's, these are your domains, and your y's, these are your ranges. Let's see, if we scan through, it looks like there's a different domain for each, so this is a function. Each domain value is paired with one range value. Vertical line test. This is a quick way to see whether or not you have a function. Just line up your pencil on each x value. Does your pencil go through only one point? If your pencil passes through more than 1 point, then it is not a function. So here's an example. If I were to take my pencil and just line it straight up, so I'm just going to pretend like this line is a pencil, and I just put it straight up anywhere, it only passes through 1 point no matter where I put it. So this is a function because it only passes through 1 point. So there is no more than 1 point on the graph for each value of x. Let's try this next one. I'm going to pretend like I have a line again. That's my point. That's my pencil. And if I put it on, that's not really a straight line. So I have a straight line, I have a pencil. It actually goes through more than 1 point at the same time. So this would not be a function because it doesn't pass the vertical line test. At least one domain value has more than one range value. So when x equals 4, 1, 2, 3, 4, there are two different y values. There's a y value here and a y value here. That's why it's not a function. All right, function rule describes the operations performed on the domain value, which is the input, to get the range value, which is the output. And this is used to write an equation that relates to variables. So here's how to write a function. you read it as f of x, so f parentheses x is read f of x, is equal to the value of the function at x. So whatever point x is, it changes the output for y. So input, this is your input, this is considered your output. So whatever you substitute in for x is going to change your y value. Okay, so in equation it looks like this, y equals 2x plus 3. In function notation it looks like this, f of x is equal to 2x plus 3. Instead of y, you just replace it with f of x for the function notation. So here's an example, when x equals 4, y equals 11, or f of x equals 11, because 2 times 4 is 8, plus 3 is 11. Okay, so y and f of x is your dependent variable. So this depends on whatever x equals, right? This is dependent on whatever x equals. So if f of x equals 4x minus 7, find each function value. So f of 5. So let's plug in 5 for x. So 4 times 5 minus 7 gets you 13. So when x equals 7, or sorry, when x equals 5, y is equal to 13. That's basically what this is saying. What about f of negative 6? So write your rule, plug in negative 6 for x. So we have 4 times negative 6, negative 24 minus 7 gets you negative 31. So when x is negative 6, then your f of x or your y is negative 31. Mariah spent $22.50 downloading songs to her music player from an online music store for 90 cents each. Identify the independent and dependent variables, then write a function to represent the total cost. Okay, so since the total cost depends on the number of songs purchased, the total cost C is dependent, and the number of songs purchased is independent. So your total cost, which is C, is equal to whatever the cost per the song was, times the number of songs. So in this case, the cost is 0.90, and we don't know how many songs she bought. So use a function to determine the number of songs that Mariah downloaded. So we have C of S is equal to 0.9S. If she spent $22.50, I'm going to write 22.5 as a total cost is equal to 0.9S. Just trying to figure out how many songs. Solve this equation by dividing both sides by 0.9, and then you end up getting 25 is equal to S. So Mariah downloaded 25 songs. Concluding thoughts, every input has one output. This is basically the very important major takeaway from this. Every input has exactly one output. Vertical line test just shows if you put your pencil up and down, does it only go through one point at a time? And f of x is just the same thing as saying y in function notation. All right, I hope you learned how to identify functions and write functions using function notation. Thank you for watching.